When current flows through a conductor, it creates a magnetic field. When two conductors with opposite current directions are near each other, they experience an attractive or repulsive magnetic force. This force can cause the conductors to move back and forth within the conduit. When a conductor carries current, it heats up. This heating causes the conductor to expand, which can lead to increased contact with the conduit and rattling. If the connections between the conductors and the conduit or other conductors are loose, they can create gaps that allow the conductors to move around and rattle. Excessive current or poor ventilation can cause the conductors to overheat. This can weaken the insulation and increase the risk of rattling. External magnetic fields or stray currents can induce voltages in the conductors, causing them to move and rattle. Conductor rattling can damage the insulation on the conductors, increasing the risk of electrical arcing and short circuits. Loose contacts or rattling can generate heat, potentially leading to overheating and fire hazards. The rattling can create a loud and annoying noise disturbance. To solve this, firstly, tighten all connections between the conductors and the conduit. Secondly, use wire supports or clamps to secure the conductors within the conduit and prevent them from moving excessively. Thirdly, fill any empty spaces within the conduit with non-flammable materials to reduce conductor vibration. Fourthly, increasing the conductor size can reduce the current density and magnetic force, mitigating rattling. Fifthly, flexible conduit can absorb some of the vibrations and prevent them from being transmitted to the conductors. Sixthly, ensure proper grounding to minimize electromagnetic interference. Upsizing the feeder before the tap may be necessary if the total load is too high for the existing wiring. Upsizing the wiring after the tap may be beneficial in reducing the magnetic force and rattling, especially if the loads start simultaneously. Here are some recommended actions. Firstly, inspect the conduit connections and tighten any loose screws. Secondly, secure the conductors within the conduit using wire supports or clamps. Thirdly, fill any empty spaces in the conduit with a non-flammable filler. Fourthly, consider upsizing the wiring on the load side of the switches to reduce the magnetic force. Fifthly, monitor the system for any signs of overheating or damage to the insulation. In more detail, the magnetic force between conductors carrying alternating current is a significant factor contributing to rattling. When alternating current flows, the magnetic field around each conductor constantly changes direction. This creates a dynamic force between the conductors. If the conductors are close together, as they are inside a conduit, the alternating magnetic forces can cause them to move and vibrate against each other and the conduit walls. The magnitude of the magnetic force depends on several factors, including firstly, the amount of current flowing through the conductors. High currents produce stronger magnetic fields and thus greater forces. Secondly, the distance between the conductors. The closer the conductors, the stronger the magnetic force. Thirdly, the phase relationship between the currents. If the currents in adjacent conductors are out of phase, the forces can be more pronounced. Thermal expansion also plays a role. When conductors carry current, they generate heat due to their resistance. This heat causes the conductors to expand in length and diameter. The amount of expansion depends on the conductor material, the current level, and the ambient temperature. Inside a conduit, the space is limited and the conductors may be in close contact with the conduit walls. As the conductors heat up and expand, they can exert pressure on the conduit and on each other. This pressure, combined with the alternating magnetic forces, can lead to rattling. Loose connections are a common cause of electrical problems, including conductor rattling. Loose connections increase resistance at the connection point. This increased resistance generates heat, which can further loosen the connection and exacerbate the problem. The heat generated by loose connections can also damage the conductor insulation and the conduit. The increased resistance to loose connection also causes voltage drop, which can affect the performance of the equipment connected to the circuit. Overheating is a serious concern because it can lead to insulation breakdown, conductor damage, and even fire. Several factors can contribute to overheating, including firstly, excessive current flow. If the current exceeds the ampacity of the conductors, they will overheat. Secondly, poor ventilation. If the conduit is not properly ventilated, heat can build up inside. Thirdly, loose connections. As mentioned earlier, loose connections generate heat. Fourthly, high ambient temperatures. High ambient temperatures reduce the ability of the conductors to dissipate heat. Electromagnetic interference can induce voltages in the conductors, causing them to move and rattle. External sources of electromagnetic interference include, firstly, nearby electrical equipment. Motors, transformers, and other electrical devices can generate electromagnetic interference. Secondly, radio frequency transmissions. Radio transmitters and cell towers can also generate electromagnetic interference. Thirdly, atmospheric phenomena. Lightning strikes can create significant electromagnetic interference. Now consider the possible dangers associated with conductor rattle. Damage to the insulation is a significant concern. The constant movement and vibration of the conductors against the conduit walls can wear away the insulation over time. Once the insulation is compromised, the risk of electrical arcing and short circuits increases significantly. Electrical arcing can generate intense heat, which can ignite nearby materials and cause a fire. Short circuits can cause a large current to flow through the circuit, which can damage equipment and pose a safety hazard to personnel. Overheating, as mentioned earlier, is another serious danger. Loose contacts and rattling can generate heat, potentially leading to overheating and fire hazards. The heat can damage the conductors, the insulation, and the conduit. In extreme cases, the heat can ignite nearby materials and cause a fire. Noise pollution is a more subtle but still important consideration. The rattling can create a loud and annoying noise disturbance, especially in industrial or commercial environments. This noise can be disruptive to workers and can make it difficult to communicate. The noise can also be a sign of a more serious underlying problem, such as loose connections or damaged insulation. Now let's look at countermeasures. Securing connections is paramount. Tighten all connections between the conductors and the conduit. Use the correct tools and techniques to ensure that the connections are tight and secure. Regularly inspect the connections to ensure that they have not loosened over time. Using wire supports or clamps is another key measure. These supports help to secure the conductors within the conduit and prevent them from moving excessively. Choose supports that are appropriate for the size and type of conductors being used. Install the supports at regular intervals along the length of the conduit. Filling empty spaces within the conduit with non-flammable materials can reduce conductor vibration. This filler helps to dampen the vibrations and prevent the conductors from moving excessively. Choose a filler material that is non-conductive, non-corrosive, and fire-resistant. Increasing the conductor size can reduce the current density and magnetic force, mitigating rattling. This reduces the amount of heat generated by the conductors, which can help to prevent thermal expansion and rattling. It also reduces the voltage drop in the circuit, which can improve the performance of the equipment connected to the circuit. Flexible conduit can absorb some of the vibrations and prevent them from being transmitted to the conductors. This is especially useful in situations where the conduit is subject to vibration from external sources, such as machinery or traffic. Ensure proper grounding to minimize electromagnetic interference. This helps to reduce the amount of induced voltage in the conductors, which can help to prevent rattling. Check all grounding connections to ensure that they are tight and secure. Finally, sizing considerations. Upsizing the feeder before the tap may be necessary if the total load is too high for the existing wiring. This ensures that the feeder has sufficient capacity to handle the load without overheating or experiencing excessive voltage drop. Upsizing the wiring after the tap may be beneficial in reducing the magnetic force and rattling, especially if the load starts simultaneously. This reduces the amount of current flowing through the individual conductors, which reduces the magnetic force between them. Let's recap the recommended actions. Firstly, inspect the conduit connections and tighten any loose screws. Secondly, secure the conductors within the conduit using wire supports or clamps. Thirdly, fill any empty spaces in the conduit with a non-flammable filler. Fourthly, consider upsizing the wiring on the load side of the switches to reduce the magnetic force. Fifthly, monitor the system for any signs of overheating or damage to the insulation. In a specific situation presented, the fact that the air compressors start simultaneously is a key factor. This simultaneous startup creates a large inrush current, which significantly increases the magnetic forces between the conductors. This is likely the primary cause of the rattling. Even the 125 run voltage drop could also be a contributing factor, especially with the simultaneous start. The National Electrical Code, or NEC, provides guidance on conductor sizing and installation. Table 310.16 in the NEC provides some capacity ratings for conductors based on their size, insulation type, and temperature rating. It's crucial to ensure that the conductors are sized appropriately for the load they will be carrying. NEC section 300.11 addresses securing and supporting wiring. This section requires that wiring be securely fastened in place to prevent movement and vibration. NEC section 310.15 provides guidance on calculating voltage drop in electrical circuits. It's important to calculate the voltage drop to ensure that it does not exceed the maximum allowable limits. Considering the inrush current of the air compressors, using time delay fuses or circuit breakers can help prevent nuisance tripping. Time delay fuses and circuit breakers are designed to withstand short duration overloads, such as the inrush current of a motor, without tripping. In summary, the conductor rattling is likely caused by a combination of factors including the magnetic forces from the simultaneous startup of the air compressors, thermal expansion of the conductors, and potentially voltage drop due to the long run. The recommended actions include firstly, inspecting and tightening all connections. Secondly, securing the conductors within the conduit. Thirdly, considering upsizing the wiring on the load side of the switches. Fourthly, monitoring the system for any signs of overheating or damage. Addressing these issues should help to mitigate the rattling and ensure the safe and reliable operation of the electrical system.